Hello everyone and welcome back. In this episode I'm going to show you how we can do our intersection test between our bounding boxes. Alright, first we have two bounding boxes, of course. In this case there is clearly no intersection because there's a small gap between those, alright? Our approach for our intersection test is we're going to look at the x-axis and the y-axis. So we're gonna look if there's an intersection on the x-axis. If we just look on this x-axis, you can see there is an intersection on this axis, all right? And if we look at the y-axis, there's no intersection because there's a gap between that. You can say we're gonna do a small kind of the separating axis theorem here, and the really most simple case. Note also that this y-axis here is not increasing to the top, okay? Our coordinate system is the other way around. Our coordinate system increases when it goes down, right? Here at the top there's 0, and right down at the bottom there is a larger value basically. Yeah, we're gonna check for the x-axis, also for the y-axis. In this case, on the y-axis there's a collision, but not on the x-axis because there's a gap. Okay, then of course there's a collision on the y-axis and on the x-axis. Then there's a collision, and what we're gonna do is we're gonna check both for y and x and see if both are intersecting, and if it is so, then we're gonna say okay, there's a collision. Then we're gonna check for the real collision. Also, these are not just shapes; these are our bounding boxes. All right. So these rectangles will always be oriented in this way. Okay, let us look at on the x-axis first. You can see our rightmost point for the bounding box A is greater than the leftmost point of the bounding box B, okay? And if it is so, then you can see there's a intersection or a collision. Then there's the other way around the case. In this case, if the leftmost point of our bounding box A is smaller than the rightmost point of bounding box B, then there's also a collision. The rightmost point here and the leftmost point here. If this one is smaller than this one, clearly you can see an intersection. And then we need to check for third case, and in this case all those three are true. All those two are true. First, the rightmost point is greater than the leftmost point for B, okay? This one, this point, this x value is greater than this one. Also, the leftmost point, this one, is smaller than this rightmost point of bounding box B. And if it is so, there's a collision for this shape. Okay, and now we can combine these two statements. Like we can combine this statement, we're going to combine this statement. This is the same statement combined, okay? Here you can see a dot left x smaller b dot right x, and this one is basically this one, okay? And this one is the other one. And if you combine those two statements for this simpler type of intersection, we can see that this is also true. So here, the rightmost point for the orange bounding box, this one, is greater than the leftmost point of x of the bounding box. So this one, okay, that's true. We can also say the leftmost point of the orange bounding box is smaller than the rightmost point of the blue bounding box. So this point is smaller than this point, which is also true. So this statement will hold for all our cases we need to check. And then of course we have the same thing for the intersections on the y-axis, and that's exactly the same thing. I'm gonna go through with this also. Here you can see a dot bottom y, so this value is greater than b at the top y, so this value. Note again, here on the bottom, our y value is greater than on the top, okay? Because our coordinate system is the other way around for y. The x is normal, there's a big value for x, there's a small value for x. So it's increasing in this way for the x-axis. For the y value, it's increasing if we go downwards. Then, of course, we have the same case like for the x-axis. Here it's a dot top y, so this value is smaller than b dot bottom y, so this value, okay. Yeah, then there's an intersection. And then we have the same case again with two statements. These are again true a dot top y, so this value is smaller than b dot bottom y. This is this value, it's true. This one is smaller than this one because our value here is smaller than our value here. And then a dot bottom y, this value is greater than b dot top y, this value. So both are true. And we can say that, this statement will hold also for the other cases, for this case and for this case. And now we can say if there's an intersection on x, for our intersection on x, we use this statement. And for intersection on the y-axis, we're going to use this statement. And then we can say if both statements are true, then there is a collision, okay? Then there's a collision, then we can say if intersection x and intersection y is true, then we're gonna check for our real collision detection algorithm, and we check for a real collision. All right, so that's it. This is our intersection for bounding boxes. We're gonna implement everything as I told you in this episode in the next one. See you there and have a nice day.